Good morning, folks. We are moving on to the next chapter here. And the good news is this is our second to last chapter. The better news is we only do 3 sections of chapter 10. So we can count on our fingers how many total sections there are left between now and summer. So the good news about chapter 10 is some of it's going to be familiar. There's a little bit of algebra 2 that gets revisited in chapter 10. And the better news is some of the words that you're seeing on the introduction slide here, I'm borrowing this from the online textbook, we don't cover. Probability, we save that for another course. If you want to take discrete math or statistics, that's covered there. Induction is a topic we don't really get around to. It deals with kind of a number sense idea and a proofreading idea, but not really important in calculus. What we are focusing on in chapter 10 is sequences and series. Probably two very familiar words to you. So 10.1 is introducing some vocab associated with sequences. We're going to spend 2 or 3 days on it because there's quite a bit of different topics here, and we are not in a rush. So we are going to slow things down for chapter 10 and our last chapter as well. So sequences. A sequence is simply a set of numbers. Um, it can be called a function, but it's really not necessarily always a function. So we have these little fancy brackets here going on here, or cursive brackets, and the sequence would be called A sub n. Now, n is simply a positive integer, as they're saying here. And all that means is it gives you, if I call n 1, 2, 3, 4, whatever it is, it's giving us, it's identifying to us that sequence's term in a longer list of terms. So a sub 17 is the 17th term of a sequence. Typically, there's some very obvious pattern associated with them. They might have a formula that you can plug into and solve for a specific term, but not always. Now, there are two different types of sequences that we're going to be dealing with. There are finite sequences, which simply mean we stop counting after some n number of positive integers. All right, so if the sequence is only counted up to n equals 20, it's obviously finite. If there is no ending point, it's then obviously infinite sequence. So pretty straightforward there. Now, working with a sequence is not that challenging because most of the times in this course, you're going to be given a very clear rule. This is called a general term, meaning a sub n, we don't know what position that is in the sequence. All right, it is the nth term of our sequence. It is the general term of our sequence. But what's nice is this formula, whatever number I plug n in, gives me that respective term of the sequence. So for instance, if I wanted the 12th term, a sub 12, I would plug 12 into the general term, simplify it, and that value I get out would be my 12th term. And that would work for any n value I want. Now keep in mind, n is always a positive integer. It represents kind of like a place in line. You wouldn't have a negative place in line, and you certainly wouldn't have a decimal place in line. So n will always and only be an integer and a positive number for the purpose of this section. Now, let's kind of just very quickly work with the general term. I want the first 4 terms of the sequence that's listed above us. So all we're doing is plugging in the numbers 1, 2, 3, and 4 in for n. So a1, the -1 stays there every single time. We're simply placing the exponent in my numerator and the exponent in my denominator with n equals 1. And we see that that simplifies step by step using PEMDAS down to -1/3. So obviously the PowerPoint's going to make this look very easy, but it takes a little bit of computation, so just be very careful step by step with the arithmetic. And A2, same thing. The -1, the 2, and the +1 all stay the same. The only thing that's changing term to term is the exponent. That is the n in the equation. A3 and A4 are listed right here. Again, you're noticing the 3 is changing for the third term, the 4 with respect to the fourth term. So here we simplified each of our 4 terms, and this would be in like a written out sequence. Not too bad. Another very common type of sequence that we will deal with is something called a recursive sequence, which of course then instead of a general term, it has a recursion formula. Basically, it defines a term based on what the previous term is all about. The easiest way to explain this and give you notation for this is just to jump right into an example. So here, it's going to identify A1 for you. Typically, recursive formulas will always do that. They'll identify at least 1 or 2 values so you can kind of get a kickstart to the sequence. But then under here, AN, this is my general term, we don't plug in here. We are saying it's 2 times the AN-1 term plus 5. And what that means is we're going to take, notice n-1 is obviously just before the n, so we're going to take the previous term, the n-1 term, and we're going to multiply it by 2 and then add 5. So if a1 is 3, I'm going to take the a1, multiply it by 2, and add 5, and all that gives me is a2. Okay, this little box here, for some reason, my PowerPoint's not registering, should be a multiplication symbol. So A2 is obviously number 11. Well, if I wanted A3, I'm going to take 11. I'm going to plug that in for the same rule. So 2 times 11 plus 5. All right, again, this time we're looking at the third, we're using the second term to get the third term. So 2 times 11 plus 5 is 27. And again, once more, we're going to do 4 terms like we did in the first example. So we're going to take 27, which is really A3, the third term in our sequence, and we're going to take that, multiply it by 2, and add 5. So 2 times 27 plus 5 is 59. And there we have our first 4 terms. Now, recursive formulas are very nice in the sense that it makes it very obvious what the pattern is. We're doubling and then adding 5. Doubling and then adding 5. They're very inconvenient though, because let's say I wanted the 12th term. The only way I could get the 12th term is if I knew what the 11th term in the sequence was. But the only way I could get the 11th sequence is knowing what the 10th sequence, the term in the sequence is, and so on and so forth. So you can recognize very quickly, this is useful for recognizing patterns, but not for figuring out a long term or a lengthy chain of a sequence. So I'm going to leave it here just as a brief introduction, just those two. I'm going to post homework on the course page for section 10.1. 5.1 is my other class. And we're going to spend probably 2 or 3 days on this section. So a lot of it might not have been covered in this video, but it will be in future videos. But if you'd like to get ahead, get a start on the homework. Good luck. If you have any questions, please reach out.